Hi guys, this is Dr. Manjunath Chennapgowd from Anveshana Academy, Bangalore, India. Dear students, in the previous class we discussed about what is diesel cycle, why the diesel cycle is invented by a German engineer Rudolf Christian Car Diesel. Why he invented that diesel engine in detail we have discussed. And also we discussed about some important process which are involved in the diesel cycle in the previous class. Dear students, in the today's class I am going to discuss in detail about diesel cycle, how it works, and how to derive the expression for efficiency of the diesel cycle that I am going to do in today's class. Fine. So diesel cycle, continuation of diesel cycle itself. So as I told dear students, we understood the difference between Otto cycle, diesel cycle. Okay, what is the importance of this diesel cycle and where we are using this diesel cycle, that all things we have discussed in the previous class. Okay, fine. Now I will move towards working of diesel cycle. So dear students, what is the working of diesel cycle? Now how he explained, okay, diesel came to know that compression ignition engine having more efficiency, more power, and we can use different fuels for run the engine, that he has shown. Then how it works now? He is trying to explain the working principle of diesel cycle in his own way. How it is, that we will study today. Okay, what he has done, cycle diesel cycle consists of four processes that you can see here now. So diesel cycle, okay, fine. The diesel cycle have consist of four processes that I already told you: compression, heat addition, expansion, rejection. Four processes. Okay, now that four processes we can show on PV diagram, PV and TS diagram. Pressure variation versus volume, we can say PV diagram. Temperature variations versus entropy, we can say TS diagram. What he has done, dear students, he has taken 1 kg of air, because in the diesel cycle we know already, initially air is get sucked into the cylinder, that air will be get compressed. That means he has taken some amount of air into the engine. That amount of air is 1 kg. For analysis or for study, what he has done, he has taken 1 kg of air into the cylinder initially. Okay, then that amount of air taken into the cylinder, right, that means what he has mentioned, that amount of air taken in the cylinder at point 1, you can see at point 1, okay, the air is get sucked. That sucked, when air is get sucked, right, that air is filled into the cylinder. That point he marked it as 1 on the PV diagram. So PV diagram, air is sucked into the cylinder, then the air is present in the cylinder. That point we can call, that means what, in terms of TDC and BDC we can say BDC. Okay, when the piston is at BDC point 1, you can call the air is sucked. That is nothing but what, how much amount of air he has taken. He has supplied 1 kg of air into the cylinder, it is gets sucked. That we can mark on the PV diagram. That's the first thing here. Now what will happens, dear students, now he sucked the air is there. That air is what actually is going to do, is going to compress. That compression we can call it as adiabatic compression. Why it is adiabatic compression? During compression there is no heat transfer from system to the surrounding, but that process, what process is doing? Compression. But if there is no heat transfer during that compression, that we can call it as a adiabatic compression. That process we can call 1 to 2. So process 1 to 2 is what? Adiabatic compression. Okay, so that is what? Adiabatic compression. Next, what will happens once the compression is over? Okay, once the compression is over, if the piston reaches point TDC. At that moment, what he is doing is going to supply certain amount of heat, or he is going to add certain amount of heat at a constant pressure. Dear students, that is the one main difference here now. But during Otto cycle, we are supplying heat at constant volume, but when it comes to diesel cycle, we are supplying heat at a constant pressure. That constant pressure means what? So P2 is equal to P3 is equal to P. That means what? At constant pressure, we are going to supply certain amount of heat. When you are going to supply certain amount of heat, right, then what will happen? Sudden combustion will take place. Then what will happen? Explosive force will act on the surface of the piston. Hence, that gas expands the piston. That means what? That hot gas will drives the piston. Hence, the piston will start to move from 3 to 4. That process we can call it as adiabatic expansion. The gas expands or drives the piston TDC to BDC, where again you can see here now there is also no heat transfer from system to the surrounding. There is no heat transfer takes place, but the process happening is expansion. That process we can call it as a adiabatic expansion process. Once at TDC, right, at a TDC, exhaust valve will be gets opened. When the exhaust valve gets opened, right, whatever the heat which is present in the gas, right, that will come out. That means what? Heat is getting rejected at process 4 to 1. How it is getting rejected? Again, see, you can say now volume remains constant. That means what? V4 is equal to V1. But here heat rejection takes place at constant volume, but heat addition takes place at constant pressure. But in Otto cycle, both heat addition and heat rejection is taking place at constant volume. That is the major difference now. This is about PV diagram. Okay, now TS diagram, temperature variations with entropy. 1 to 2 is what? Compression, right? Adiabatic compression. What happens now when the air is get compressed, right? The temperature is going to increase from what? T1 to T2. Again, at 2 to 3, what we are doing now? At 2 to 3, we are going to supply certain amount of heat now. 2 to 3, we are going to supply certain amount of heat by supplying fuel, actually, because the air is already compressed. When the air is already compressed, right, it is going to have a 250 degrees Celsius. If you are going to supply small quantity of diesel, if you inject it, then what happens? Sudden combustion will takes place. That means what? Addition of heat, actually. That means what? At process 2 to 3, you are going to supply certain amount of heat. That heat addition is represented by QS. But what is the condition? You are supplying heat at constant pressure. Okay, fine. Once the heat is added, right, then what will happen? Sudden explosive force is going to create over the surface of the piston. Hence, what will happen? Piston will start to move from 3 to 4. Then what will happen? Now, here, dear students, with respect to temperature, T2 increases to what? T3. If the sudden explosion combustion takes place now. Now, what will happen? Piston will start to move from 3 to 4. The expansion, that temperature is going to decrease from T3 to T4. Again, if the heat is get rejected, then what happens? Temperature is decreased from T4 to T1. This is what? Cyclic process now. So, what are the 4 processes, dear students? You can see here now. Okay, in the first process, just a minute. Okay. What is first process? Adiabatic compression, or we can call it as a sudden compression. That we can call it as a isentropic compression. In isentropic compression, what I told, the air is get compressed adiabatically. If air is gets compressed adiabatically, then what happens? The temperature increase from T1 to T2. The pressure increases from P1 to P2. That is what? First process, that is isentropic compression. Okay, next process 2 to 3, you can see now constant pressure heat addition. At constant pressure, you are going to supply certain amount of heat. Then what happens now? Temperature increase from T2 to T3, pressure increase from P2 to P3. Okay, that is nothing but what? Constant volume heat addition. How we are adding heat? As I told you, student, just you are going to supply certain amount of diesel in injecting. You are going to inject some amount of diesel into the cylinder at process 2 to 3. But in petrol engine or Otto cycle, what we are doing, with the help of spark plug, we are giving heat addition. But here, with the help of injecting small quantity of diesel, what we are doing, we are adding the heat. That too at what? Constant pressure. Pressure remains constant. Hence, P2 equal to P3. So, P2 is equal to V3. That is what? Heat addition. Next process, if the heat is added, right, sudden expansion will take place, right? Then what happens now? Piston will start to move from TDC to BDC. Again from point 2, point 3 to point 4. Again what will happen now? As I told, there is no heat transfer at all. The hot gases expands adiabatically. Hence the piston will be moved from TDC to BDC. That is what isentropic expansion, or we can call adiabatic expansion. If it is happening suddenly, that we can call it as isentropic. Okay, fine. Now once it done, right, 3 to 4, then what happens? 4 to 1, heat is going to reject. So exhaust gases are expelled at constant volume. That means what? They are coming out, hot gases, they are coming out at 4 to 1. That means what? Heat is getting rejected at constant volume. Hence V equal to constant, we can say. These are the 4 important processes we are having in diesel cycle. Okay. Fine. Now I will move towards next step. Now in detail we will study how the diesel cycle works. Actually we told with the help of PV diagram, I explained you. Actually I will try to explain you step by step. Process 1 to 2, 2 to 3, 3 to 4, 4 to 1, with the help of a schematic diagram of the piston and cylinder arrangement. So dear students, you can see here now the first step is what? Isentropic compression. In isentropic compression, what happens? I will start with what? Compression. My initial point is compression, because before that air gets sucked into the cylinder. I will start with what? Compression, first step. Okay, so in the compression step, what we are doing? We are going to compress air adiabatically. That means what? We are not at all transferring heat from system to the surrounding, but we are compressing the air. When we are going to compress the air, right, what happens now? There is a rise in temperature as well as pressure. How it is, that we can see here now. That we can call it as a first process, that I can call it as a adiabatic compression or isentropic compression. How it is, that you can see here now, dear students. So I will start with, as I told, first point is my BDC, second point is my TDC. Initially assume that air is sucked into the cylinder. Now piston is at BDC. Now what I will do? I will start to move piston from BDC to TDC. That means what? I will start with what? First process, that is compression. When we are going to compress the air, right, then what happens now? Here, dear students, you can see here now. As I told, there is a rise in temperature. That means what? Temperature increased from T1 to T2 and pressure increased from P1 to P2, but volume decreased from V1 to P2 during what? Isentropic compression or adiabatic compression. Since when the piston moved from BDC to TDC, compression takes place. If the compression takes place, temperature increases, pressure increases, whereas volume decreases during what? First process, that is isentropic compression. Okay, hope you understood first process. Second process is what? Second process, you can see, dear students, constant volume heat addition. Now the piston is at particular this point, right? At that point, what you are doing? You are going to add certain amount of heat, that you can see here now, dear students. What is that? That is what? What is that? Constant volume heat addition. Now the piston is at TDC. When the piston is at TDC, the temperature of air is T2. That means what? More temperature. That pressure also increased. What I will do? The air, whatever I have taken, right, it is at high pressure and high temperature, around 200 degrees Celsius, 250 degrees Celsius air is the compressed air is having that much temperature. If you are going to supply certain amount, small quantity of diesel, I will inject small quantity of diesel into the cylinder at T2 and P2, then what will happen? Sudden combustion will takes place. That means what? If you are going to add certain amount of fuel or diesel into the cylinder, right, that means what? You are going to add certain amount of heat to the air at constant pressure. That means what? When you are going to compress the air, right, that when the piston is at TDC, right, that means what? Whatever the pressure inside the cylinder, right, that is attained equal. That means what? The pressure remains constant at all points. At that moment, we are going to supply certain amount of fuel. That means what? We are adding certain amount of heat to that particular condition. That is nothing but what? Constant pressure heat addition. In that, what I have done? I injected small amount of fuel at constant pressure and temperature. Okay, fine. That is what constant volume, sorry, constant heat addition at constant pressure. That is what second point. Then third point, if you added heat, then what happens now? Sudden explosive force is going to create or exert over the surface of the piston. Hence, what happens? The piston will start to move from TDC to BDC. That process we can call it as a adiabatic expansion. Dear students, because of heat addition, that is QS, then what happens? Sudden combustion will takes place, hot gases they are going to form, that hot gases they are going to exert explosive force over the surface of the piston, hence the piston moved from TDC to BDC. TDC to BDC. If the piston moved from TDC to BDC, that means what, it is getting expanded, but there is no heat transfer at all. That process we can call it as a adiabatic expansion. If it is happening quickly or suddenly, that we can call it as a isentropic expansion. So that third process is isentropic expansion or adiabatic expansion. In adiabatic expansion, what actually happened? Hot gases expand adiabatically, hence drives the piston from TDC to BDC. That is nothing but what? Adiabatic expansion or isentropic expansion, that we can call it as a third process, dear students. Then what is fourth process now? What is fourth process? Constant volume heat rejection. Then what we will do? The piston will be at TDC only. We are going to open the exhaust valve. When we are going to open the exhaust valve, right, the whatever the hot gases is there inside the cylinder, right, that hot gases will come out. When the hot gases is come out, means what? Heat is getting rejected through hot gases. That heat rejection is represented as a QR. The heat is getting rejected through hot gases. When at again what? Constant volume. What volume remains? Constant. At constant volume, heat is getting rejected from cylinder to the surrounding. That we can call heat rejection at constant volume process. Constant volume process. Okay, that you can see now. What actually happened in the constant volume? Heat rejection. The exhaust gases expelled at a constant volume. They are coming out at a constant volume. That we can call it as a constant volume heat rejection. These are the four important, that process we can call it as a fourth process. These are the four important processes we are having in the diesel cycle, dear students. Okay, fine. Now, so to understand the diesel cycle, we should know some basic terminology or basic components which are there in the diesel cycle. So, okay, diesel cycle or diesel engine, we are having fuel injector instead of spark plug. Spark plug we are using in Otto cycle or Otto engine, but here we are using fuel injector. With the help of that fuel injector, small quantity of diesel will be added at a constant pressure at the end of the compression. That is fuel injector. Inlet valve and exhaust valve we are having. Cylinder head, it is a closed system, hence what happens, the heat may transfer from system to surrounding, but here in this application heat is not at all transferring, hence it is a adiabatic process. During compression, during expansion, there is no heat transfer takes place, hence we can call both compression and expansion are adiabatic here now. Then this is a piston. This is a piston, dear students. At the top of the piston there will be a chamber. That chamber you can call it as a combustion chamber. And this is what? Cylinder. Okay, that cylinder, the piston is moving up and down. That you can see, it is moving up and down. Sorry, up and down. Okay, this is what connecting rod. It is connected to crankshaft. Hence, it is going to rotate at a speed. That speed we can mark it as an N actually. And dear students, to understand this diesel cycle or to do derivation or to solve numericals, we should know what actually this terminology. What is VC? VC is a clearance volume. What is TDC? Top dead center. What is VS? Swept volume. Then what is length? Capital L. That is nothing but a stroke length we are calling. That means it is the distance between BDC to TDC. Okay. So BDC is the bottom dead center. Okay. So you can see here now. What is VC? VC is a clearance volume. The distance between cylinder head to TDC we can mark it as a X. The whatever the volume which is going to occupied from cylinder head to TDC is nothing but what? Clearance volume. The volume of the air which is occupied between TDC to BDC we can call it as a swept volume. How to calculate that swept volume? I already explained. Swept volume we can calculate. What is that swept volume? We have the formula, right? Vs is equal to 5 by 4 into d square into L, where is L is stroke length, d is the bore diameter. Okay, that you can see here now. So what is D? D is nothing but what? Bore diameter. Okay, BDC is bottom dead center, whereas TDC is a top dead center. The students, how that diesel cycle works, that you can see now. Initially, I will take this as a point 1. Initially, just a minute. Assume that initially piston is at point BDC. You can call it as a BDC. This you can call it as a TDC, top dead center and bottom dead center. Assume that initially the piston is at BDC, bottom dead center. That is nothing but a starting point. Air is already sucked into the cylinder. Now what we will do, we are going to compress that air. Okay, what we are doing now, we are moving piston from BDC to TDC. From piston BDC to TDC. 1, 2 we can call. This point we can mark it as a 2. Okay, the piston is moved from BDC to TDC. Hence, whatever the air which is there inside the cylinder, right, it is get compressed. When it gets compressed, right, the pressure increased from P1 to P2. Temperature increased from T1 to T2. Whereas volume decreased. Okay, fine. Now, when the piston is at TDC only, that means whatever the pressure is there inside the cylinder, right, that air, whatever that air having pressure is remains constant. The pressure remains constant. It gets stable. At that time, what we are going to do, we are going to supply certain amount of heat. How we are going to supply certain amount of heat? We are giving small quantity of, or we are injecting small quantity of diesel into the cylinder. That means what? Heat addition takes place at constant pressure. At constant pressure, that is 2 to 3. So kept constant. Okay, cylinder is at TDC only, the pressure attains constant. At that time, we are going to supply certain amount of heat. Hence, what happens? Heat addition takes place at constant process. That is nothing but constant process is nothing but what? 2 to 3. Okay, 2 to 3. Once the heat addition takes place, right, then what happens now? Explosive force is going to create over the surface of the piston. Hence, what happens? The piston will start to move from TDC to BDC. The next cycle we can call it as a point 3 and 4. The piston will start to move from TDC to BDC. That means what? From point 3 to point 4. That means what? Expansion will takes place. Okay, once the expansion will takes place, that means what? Piston will move from TDC to BDC. That means what? That gas drives the piston. Hence, it make piston to move from TDC to BDC. Once the piston reaches from TDC to BDC, it is going to reach from point 3 to 4. Once it reaches from 3 to 4, then what happens now? Expansion work takes place. After that, the piston will retain at BDC only. What we are doing? We are going to open exhaust valve. When we are going to open exhaust valve, right, the hot gases, whatever it is there, right, that will come out. When the hot gases there come out, right, that means what? Through that hot gases, the heat also expelled, heat also removed from cylinder to the surrounding. That means what? Heat rejection takes place. So then what happens? Once it takes place, then what happens? All the hot gases which are present in the cylinder, right, that will come out. Then once they come out, right, exhaust valve will immediately gets closed, inlet valve will be open, the air will be gets sucked, and that inlet valve also closed. Then what happens now? Air will be get filled into the cylinder. Then again from point 1 to 2, what we can do? We can compress. That is a continuous process. This is what? How the diesel cycle works. Okay, how the diesel cycle works, dear students. 1 minute. Fine. How it works? Diesel cycle works. Okay, so just for understanding, I have explained these all things, different stages, how they work actually. So I am going to stop here. I will try to do I will try to do derivation for efficiency of diesel cycle in next class. Okay, dear students, I hope you understood the derivation well. No, sorry, understood the concept of diesel cycle. What are the important process? How they work? That you understood well. If you understood, if you like, please do comment. Thank you. Please do subscribe and support me, Anveshana Academy.